My dear friends, we have been talking about the generator protection, and this is generator protection 10 and the concluding video, because in this video we will complete the generator protection. We are discussing abnormalities in generator. Last we discussed the pole slipping. So next abnormality is backup mode. Abnormality, or you said so to say, is a backup protection. You see, the fault has occurred on transmission line. I have shown to you the complete one-line diagram. That is, there will be a generator, then there will be generator transformer, then there will be 52G, that is generator breaker, then there will be infinite bus, and from there 7, 8, 9, 10, whatever is the requirement, lines will emanate. Now on one of those lines there is a fault. That will be obviously cleared by distance protection of line. Because you see these lines are 220 kV, 400 kV lines, so distance protection is there. If distance protection fails, then overcurrent and earth fault protection of that line will back up. If that fails, then class C protection we talked about is the in generator transformer secondary, there is overcurrent and earth fault protection. That will give backup. And if that fails, you see, just see, it's not, it is next to impossible that 3 protections will fail. Then it comes to, in fourth line of defense, it comes to generator. But as I was telling to you, generator is a very costly equipment. We do provide this protection. Now, backup protection, you cannot have overcurrent protection, because I told you, 3 protections will fail, and each are time delayed. Distance will immediately operate, but overcurrent will take some time delay to give backup. Transformer overcurrent protection will take further time delay. So by that time, generator reactance due to fault has come to steady state region. That is, now that the fault is facing the synchronous reactance of the generator. Synchronous reactance of the generator, XS or XD, whatever you call. The value of XS is 225%, and therefore fault current is less than half the rated current. So you cannot provide backup. You cannot provide overcurrent relay for backup because it cannot be set. You cannot monitor the overcurrent relay by under voltage relay also, because under voltage will not occur. The AVR will correct the voltage to normal. So you have to depend on distance relay. So backup in generator is provided by backup offset mode relay, shown number 2. Offset characteristic number 2. This characteristic is given. Offset is useful because you see some 25%, because it is provided on generator terminal, so some 25% of generator winding also it will cover. So that way offset is useful. So much offset is useful. And another thing is shown is this backup mode relay and the field failure relay are not intersecting. If you use backup impedance relay, then they will intersect, and due to field failure, the backup mode will operate, which is wrong. So the correct choice is backup mode and not the backup impedance. So, and how will you set the relay is set for the, I mean the impedance of the relay is set for the longest line that is emanating from the bus, so that the complete generator is backed up, is backing up the longest line. So now there is no problem, right? So that is how the backup mode relay operates. The next protection. The next protection is under frequency protection. Due to inadvertent splitting of the interconnection of the power system. That means, you see, now we are connected with Maharashtra, Rajasthan. So if there is those breaker trips because of some unknown reason, or somebody trips manually, then the isolated area, so you see, either Gujarat or Maharashtra may face the overload and Gujarat may face the overload. Both are Gujarat may face the underload. Both are wrong, because in both the cases the system can go out of step and the cascaded tripping can occur. So and the speed of the generators will increase, means on one side there will be over frequency, on another side there is under frequency, or otherwise you are joining the abrupt load to the generator, then under, or load is more than generation, then also under frequency will occur. Nowadays, you see, and on 66 by 11 kV substation, some 10, 11 kV feeders are outgoing. So some 2 or 3 feeders are identified, and if the frequency goes down below 49.8 or 49.9, then those feeders will automatically trip. I mean, with under frequency, tripping is arranged. With under frequency relay, tripping is arranged. Tripping is in the schematic itself, protection schematic, tripping is arranged. So occurring of under frequency is now rare, because people are very cautious about under frequency, because under frequency is uh, a reason which can lead to the cascaded tripping. But say if you cannot shed the load, then frequency goes down. That means the speed of the generator goes down. Nothing happens to generator, but speed of the turbine gets reduced. And speed is reduced, therefore the flow of the steam will reduce. And if flow of the steam gets reduced, then not in HP turbine, may not be in IP turbine, but in LP turbine also, if there are 6 or 8 stages, then last 2 stages particularly will be, the steam will be condensed in last 2 stages and turbine blades will be damaged. It is said that if the frequency is less than 49.7 or 49.6, or if it goes below 46 hertz, then the life expectancy of the turbine, that means if turbine is designed for 15 years, then it will live only for 10 years. Therefore, for these conditions, as I told you, automatic load shedding is used for the frequency protection. So now we have restructured the power system, and we are applying availability based tariff, right? That means if the generation is less and load is more, then automatically the consumer will be charged more. So if we would not like to use power at a higher rate. So, or other thing also, that I have to maintain my power factor. If I'm a consumer, then in BVM Engineering College, I was the in charge of power monitoring committee. So I had to see the power factor continuously. I mean, I told some person to see at every half hour, every 15 minutes, he should check the power factor. Actually, we had the automatic capacitive bank, so that if the power factor is less, the capacitors will be connected. So that was not happening. But manually also we were checking that we have to maintain the power factor at 0.95. If our power factor is 0.94 or 0.93, then we have to pay penalty when the last bill comes. But if we improve the power factor 0.96 or 0.97, then we will getting some rebate in rather bill. So we would be, I mean, the consumer is uh, consumer is so to say, uh, consumer would like to keep the frequency higher, as high as possible, because he will get rebate in his, because many consumers are paying, many big consumers are paying. Say we were paying some minimum 1 or 2 lakhs of rupees of bill in BVM Engineering College. So large frequencies may be paying 5 lakhs or 10 lakhs. So if 2% or 4% rebate is given, it is a big amount. So uh, these all things after restructuring of power. You see, earlier it was GB, now JETCO transmitting people, MGVCL, UGVCL, PGVCL, DGVCL are distributing people, and GSECL is the generating agency. So people are uh, independent, and they can impose the law what they like. So accordingly now, in Gujarat, we are not facing the problems of cascaded tripping or, so to say, uh, in, instability in power system. But otherwise, under frequency is very serious. But under frequency is class B protection because there is no fault. Load is more. So under frequency is class B protection. And usually it is in 2 or 3 stages, that if the frequency is less than 49.9, then the alarm will be sounded after some 4 or 5 seconds. If it is less than 49.8, yet the alarm will be sounded. But it will be a different router, sound will be different. So person will come to know that the alarm frequency is decreasing. And if the frequency decreases below 49.7, then it will trip. So the numerical relay manufacturers are giving the under frequency protection in 3 stages. Over speeding, as we were discussing, steam is a very low viscous fluid. So if the generator overspeeds, you can throttle the steam control valve and you can bring the speed to normal. Speed governors are also there, which will give command to the throttling steam control valve automatically. So you have not to do anything. If the things fail, auto control fails, then you can take from auto to manual and you can manually control. But in hydro, the problem is there is a problem of uh, the hydro water is a viscous fluid, so you cannot stop it immediately. Right? So there is a possibility of hammering action on steam water control valve. So there, over speeding protection, over voltage, over frequency, over speeding, all protections are provided in hydro machines. The next problem is stator overheating. The main cause of stator overheating is ventilation failure. That is the distilled water is not, flow of distilled water is not proper. The pressure of distilled water is not proper, or you are overloading the generator, or the hydrogen cooling system fails. So some laminations are short-circuited of stator and failure of core bolt insulation. These are the problems of overheating. Usually at many places in the stator, RTDs, resistance temperature detectors, are kept, and resistance temperature detector means there will be one resistor, the resistance of which will change very fast with increase in temperature. So wherever there is a local spot, because you see overheating, if the uh, uh, lamination fails, so in that spot only there will be overheating. So that is very difficult to judge. It cannot be judged by any overcurrent relay. So RTD nearby will judge this. That will be heated up. Right? So there will be many RTDs on generator stator. So those RTDs will sense. RTD actually is like this. It is like a bridge. RTD is also a resistance, but the resistance of it will change very fast with the heating, with when it is heated. R1, R2, R3 are manganese resistors, and they are fixed resistors. They will not change. But it forms a Wheatstone bridge, and with normal temperature, with nothing is occurring, the bridge is balanced. But when some local spot is heated, RTD resistance will change, and the bridge is imbalanced, and current will pass through the relay, which is connected as shown, right? So the relay will operate, and it will sound an alarm usually, because overheating is not so important that you should trip the generator. Usually it will sound alarm, but if the heating is too large, it may be tripped also. Uh, Another small abnormality is bearing failure and bearing overheating. Thrust bearing particularly. Thrust bearing means when 140 kg per centimeter square pressure steam is thrown on the turbine, is uh, given to the turbine, the whole turbine moves that side on one side, and bearing will be pressed. So I was told that the cost of the thrust bearing is somewhere around 20 lakhs, and cooling of thrust bearing is very particular. I mean, it is very complex arrangement. It has to be cooled by oil. There will be oil seal also, because hydrogen should not come out. And that oil has to be replaced because it is heated, and it will taken to coolers. It will cool and come back to the bearing. That uh, loop circuit will continue. So if that bearing fails and bearing overheats, that is a uh, that is a that is an abnormality, because of which an alarm can be sounded, or if the things are too much out of control, then tripping also can occur. But for that, you see, as I told you, the pressure, flow, and temperature of distilled water at the entry and at the exit are checked continuously, and similarly the pressure of hydrogen and temperature of hydrogen uh, is also seen in control room. So control room engineer knows all parameters, and if any parameter goes out of order, so uh, the generator control is a very important thing. Nowadays, people are preferring auto control. So in earlier days, when I was seeing, there were some 10 people in one control room for controlling one generator. Now hardly there are 3 people, because everything is microprocessor based. Everything is uh, digital signal processor is there, and the auto control loop instrumentation is using DSPs, and auto control is there. So the person has only to see that auto control is properly working. If it is not working, then he has to change over he has a switch on his panel. He will change the switch from auto to manual and he will do manual. So temperature of the oil can be monitored by an instrument with an alarm contacts. The failure of oil cooling equipment is detected in large machine by comparison of inlet and outlet temperature of oil. Because in bearing, there will be oil coming and oil going and coming out. So temperature should increase. If temperature is not increasing properly, then there is something wrong with the bearing. And it is not only thrust bearing, journal bearing also the same procedure has to be followed. So that is generator potential transformer fuse failure. You see, many protections are using voltage. Say pole slipping protection is using voltage. Generator backup more relay is using voltage, right? The if you scan through different type of protections we have studied, then you see generator 100% sensitive earth fault protection is also. So any protection that is using voltage, there this problem is there. You see, you have to protect generator PT, and for protecting in secondary there is HRC fuse. If HRC fuse, if there is a short circuit in secondary, which is quite possible because secondary is just 110 volt. Somebody may forget some instrument on the bus, generator PT secondary bus. Anything can happen, because of which generator PT will be short circuited. It is said in power system that CT should never be open circuited and PT should never be short circuited, because PT is hardly taking few milliamperes of current. So generator PT fuse failure generator PT has to be kept, but when generator PT fails, it is not providing enough voltage to the relay and relay may maloperate. So the circuitry that we had seen in distance protection, right, which uses the fuse failure relays, will rather avoid the unwanted tripping, non-required tripping. That will be avoided by that circuitry which we had seen in distance protection. So friends, so to say, generator protection ends here. We have seen all abnormalities, but we just have a look at this. How many protections are class A? How many protections are class B? How many protections are class C? And how many abnormalities are causing only alarm? Neither class A nor class B nor class C, and only alarm will be run because the abnormality is not serious. Nothing is going to happen to generator immediately, or within a minute or two also nothing is going to happen. So in that case only alarm is sounded to let the person know that this abnormality has occurred. And I am particular to show this because you see, not only electrical reasons, electrical causes, electrical relay operation, but also certain mechanical things will initiate class A protection. So I am listing differential protection, stator earth fault protection, inter-turn protection, overcurrent and earth protection in case of small generators, rotor second earth fault protection, over voltage protection, reverse power protection, pole slipping protection, generator transformer overall differential protection. That we will see transformer protection in the next classes. Local breaker backup protection. See that for that we'll have to see the bus zone protection when we'll see the bus zone. So bus zone protection also on 220 kV bus on which the generator is connected, that can also initiate class A trip, because some line breaker is not tripped, and therefore all breakers you are tripping. Once you trip the generator breaker, generator is isolated from the bus, so you have to stop the generator. So local breaker backup protection. So many protections you will see that they are not in generator scope, they are in transformer scope or in bus scope or in transmission line scope. Generator transformer restricted earth fault protection. Because you see generator transformer, between generator and generator transformer there is no breaker. Differential protection of unit auxiliary transformer. Because between generator and UAT also there is no breaker. So generator has to tip. Generator transformer over fluxing protection, that we will see in transformer. Generator transformer Buchholz strip. Buchholz, there are two contacts. One is alarm contact and another is trip contact. That trip contact will initiate the class A protection. Right. So many are class A protections. Yes, continued. Class A protections. Generator transformer pressure relief device operated. Right? Because if a large voltage occurred, then the generator transformer, then big amount of oil will be converted to gas, and that gas will be entrapped in the uh, conservator, and then conservator will burst. It can burst the generator transformer hole also. So there is a pressure relief device. We call it explosion vent also, where there is a aluminum diaphragm, and because of pressure it will break and the gas will come out, so that the generator transformer cannot blast. Unit auxiliary transformer Buchholz strip. Unit auxiliary transformer pressure relief device operated. Unit auxiliary transformer OLTC Buchholz strip. OLTC is given. Unit OLTC means on-load tap changer. Unit auxiliary transformer instantaneous overcurrent protection. Overcurrent protection of excitation transformer. You see, rotor side we are coming now. Generator rotor over voltage relay. Generator rotor is, if it over voltage occurs, then class A trip. Thyristor block failure of static excitation system. In brushless excitation system, if thyristor block fails, then class A trip will start. Generator transformer and unit auxiliary transformer multi-fire. That means if there is a fire, कहीं आग लग गई, because generator transformer there is oil and oil is inflammable. If there is fire, then there is special multi-fire system. If you go to substation or power station, there is blue pipeline. That blue pipeline is containing water and CO2, etc. So if firing occurs, it will break. Some, because of fire, because of heat, some uh, diaphragm will break and water will be thrown. Water cannot be thrown because water is electrically conducting. So carbon dioxide or some gas is thrown so that fire extinguishes. But then when firing occurs, then the class A trip will occur. Automatic voltage regulator failure relay operated. And vacuum failure. You see, this is purely mechanical reason. Vacuum failure, if vacuum is not enough, that means pressure at the outlet of the LP turbine is more, it is not vacuum, then class A protection will operate. Right? Class B protections. NPS protection, negative phase sequence, field failure protection, backup impedance or backup mode, under frequency protection, generator transformer, oil and winding temperature very high. You see, winding temperature indicator is there. Winding temperature is measured by some RTD. So if winding temperature increases in generator transformer, and if it is high, then alarm will be sounded, and very high means class B protection will operate. Similarly, unit auxiliary transformer backup overcurrent protection. Unit auxiliary transformer winding and oil temperature very high. Excitation transformer temperature very high. Thyristor fan supply failure. Stator water conductivity is high. Stator water should be insulating. Its conductivity has to be measured, because you see, otherwise person may get shocked. So if stator water conductivity is high, class B protection will operate. Stator water flow very high, then it will not be able to take away the heat, because flow is fast. So that should not happen. If it is high, very high. Say you see, wherever you find very high, at high stator water flow high, alarm will be sounded, and very high class B protection will operate. Master fuel tip relay. This is not electrical reason. Master fuel trip relay of boiler has operated. Means boiler is not getting fire. It is not converting water to steam. LP, HP heater water level very high. LPHP heaters are there. This is a mechanical reason. Water level is very high. Inside the heaters, water level should not be high, because it has to give away the heat to steam. And because the level is high, it is not giving away the heat, because you see, inside there can be sledging. That means inside there can be the sledging has occurred. So it is not transferring properly the heat. So uh, these are the reasons. Not only these, yet continued. Thrust bearing of turbine fails. Lubricating oil, turbine bearing pressure very low. Once again, very low. Very low means if it is low, alarm will be heard. And very low, lubrication oil temperature, lubrication oil pressure is, if it is very low, then class B protection will operate. You see, this is many reasons are mechanical. You will see boiler drum water level very high. If it is very high, then the steam at the top will be having more water droplets, and those water droplets will go to turbine, and turbine blades will be damaged. So boiler drum level should be exactly halfway through. It is a cylindrical drum, and lower half is water, upper half is steam. Turbine bearing temperature very high. Turbine bearing temperature is, if high, then alarm. Very high means class B protection. HP turbine inlet pressure low. HP turbine inlet pressure should be 140 kg per centimeter square, 120 kg per centimeter square, whatever is the design pressure. If it is low, then class B protection. Loss of boiler water. Boiler is not receiving water due to one or the other reason. Maybe BF pump, boiler feed pump might have failed. Loss of ID fans. If ID fans strip, then class B protection will operate. Loss of FD fans. Condenser water level high. In condenser also, water level should not be high, because then it is not transferring heat. Excessive overfiring in boiler means the temperature in the boiler is very high, you are overfiring the boiler. This is also purely a mechanical reason, but operation is electrical, class B protection. So this is very interesting, this list. Class C protections only two: generator transformer backup earth fault and generator transformer backup overcurrent operates. That is only for line faults. If line relay fails, then generator transformer will give backup, and then 52G will trip. But generator will keep on running on house load. That is class C protection. Then what are the conditions causing alarm? In this, only alarm is sounded. Overload. So in air-cooled steam turbo alternator or hydrogen-cooled or hydro machines, this facility is there. Rotor first earth fault protection. That is also there in all the three kinds. Condenser vacuum blow. That is, condenser vacuum blow is only in steam machines, not for hydro machines. Hydrogen pressure, temperature and density abnormal. That is for the alarm is heard in steam turbo alternators. Bearing temperature low. That is in all the three machines. Stator temperature high. That is in all the three machines. Rotor vibration. Rotor vibration will occur in case of rotor earth fault. Or maybe the rotor is not properly balanced. That is, dynamic balancing is not properly done, then vibration will occur. That also alarm will be sounded in all the three cases. Generator PT fuse failure. Battery voltage low and automatic voltage regulator failure. So you see these conditions, and I don't know further. No. So many conditions will give alarm. In Appendix 2, I have shown the field suppression. Field suppression is required because you see, you are tripping the field breaker in case of Class A or Class B protection. But when you trip the field, in field 500 ampere was flowing, and immediately you are bringing it to 0. So di by dt is very large. And if di by dt is very large, the large EMF will be induced and field winding insulation will be damaged. So you cannot open the field immediately. But what we are doing, we are using make before break type switch. So the switch that you are seeing on field breaker, it will first it will come to this. First it will come to this and this terminals. It will not leave this terminal. Then it will go below and it will leave this terminal afterwards. So that field is connected across resistor. So that L I square, 1 half Li square, जो हम कहते हैं, the electro magnetic energy that is produced, which is a reason for overvoltage, that is dissipated in resistance. Right? So this is known as field suppression. This is always provided in any kind of generator. That is a must. So with this, one more appendix we see information required for designing protection scheme for generator and relay setting. If you want to set the relay and if you want to design the protective system, what you should know, you will have to know many things from generator manufacturers, generator transformer manufacturer, CT manufacturer, relay manufacturer, because you are engineering everything. You are bringing all together, all things together. So what you need is active power rating in kW or MW. kVA, MVA rating of kVA for small generators, MVA for large generators. Voltage rating of a generator. Full load rated current of a generator. Through fault withstand. Synchronous reactance excess. Direct axis transient reactance XG dash. Direct axis subtransient reactance XD double dash. Negative sequence reactance X2. Zero sequence reactance X0. Nature of cooling the stator winding. Are cooling by water or what kind of cooling? Nature of cooling the rotor. We are using hydrogen, but that has to be informed to us. Then I2 square T withstand constant K of generator, that generator manufacturer will provide. Generator NPS withstand current. That is usually 5%, but you have to ask to the generator manufacturer. Allowable sleep, that also you have to ask the generator and overload withstand, that the generator manufacturer will give you a curve, overload withstand. So these many things you have to ask from generator manufacturer to design the protective scheme. Current transformer, you have to ask class of CT, knee point voltage, magnetizing current at full, at kPV, at half kPV, and at 1/4 kPV. CT secondary resistance, you have to ask CT ratio, and uh, uh, these many things are must, but other requirements are engineered based on generator particulars and type of protections employed. So many other requirements are there, which we are talking while we are talking the different kinds of protection. Say for generator differential, we say that knee point voltage is 2 times IF RCT plus RL. So like that, many current requirements are there for CT. So that is based on type of protection. Information, other important informations required are pilot lead resistors from geography of the power plant. Types of relays used for different types of protections and their technical particulars. You must know what relay you are using and their technical details you should know. Otherwise, you cannot design. I mean, you cannot set the relays. Neutral grounding transformer. You should know the kVA rating. There is a formula, uh, but you should know that voltage ratings of primary and secondary. Usually, line to line voltage is the primary voltage of the NGT and 240 volts is secondary voltage. Continuously rated or intermittently rated, because NGT is not coming in picture normally. So it is usually not continuously rated. It is intermittently rated. Type of earthing of the neutral. Whether you are using resistance or reactance or any kind of different earthing. You are using Peterson coil, that you should know. Whether the earthing reactor is continuous duty or intermittent duty. Earthing reactor is not in circuit when normal working is there. It's only for line to ground fault. Voltage rating of the reactor and current rating or power rating of the reactor or resistor. Potential transformer, voltage ratio, and VA rating. So these many things you should know. With this, my friend, we are completing generator protection, and in the next class we will enter into large power transformers. I mean protection of large power transformers. So if you want to, if you are interested, please stay tuned with Head Up Me and share this knowledge to as many friends as possible, because in Sanskrit we say that Vyaya krute vardhate vanityam. That means the vidya dhan, the education is such a thing that if you dispense, if you use, that means if you give to others, if you give money to others, you will have that much less money. I have 100 rupees in my pocket, I give 25 rupees, then 75 rupees will remain. But here education, I have 100% or I have 70% and I give 20%, तो मेरा तो 20% बढ़ जाएगा. If I have 70% of knowledge and if I give 20% to somebody, my knowledge will be 90%. I don't know about you, but my knowledge will be increasing. Vyaya krute vardhate eva nityam. That is what is told by Rishiminis years before, thousands of years before. They told that the Vidyadan, the education, if you give to somebody, if you educate somebody, if you share what you know, then you will know more. That fellow will also know if it is attentively hearing you, but you will know more. I am knowing more when I am giving to you. So I would request you that if you are really hearing and attentively hearing and attentively seeing the full video, then share with as many engineers as you can, as you know. Until then, thank you, my friends, and good day.